Here we are again with a question from projectile motion. A particle projected with velocity 30 meter per second at an angle theta with the horizontal and theta is given. So after the 1 second, the direction of motion of the particle makes an angle alpha with the horizontal and we have to find what tan alpha. First of all, let's draw a small graph related to the question. So we know that this is x-axis, which is the particle will do horizontal motion, and this is along the y-axis the particle will perform the vertical motion. If this is the origin and this is the particle get shooted and it is projected, right? It's projected, object is projected, so it will be projected at some velocity and the velocity is given, it is 30 meter per second. So we know that we will split it into components like vertical component and one is horizontal component. What is horizontal component? It is and also remember theta is the angle made by the particle velocity with the horizontal axis. So the u and it is 30 cos theta. Here it will be 30 sin theta. So what we actually obtain now? It is ux and uy. Ux is nothing but this component and that is 30 cos theta and here it is 30 sin theta. So we have to remember kinematics equation. What is the kinematic equation we need here? It is v is equal to u plus at. Here we have to find the v, which is one is a vertical component and one is a horizontal component. So equations turns ux and uy, ax and ay, t. We have to know that the acceleration along horizontal motion of the particle, it is 0, and acceleration along the vertical component, it is minus g, and the value of g is actually 10 meter per second. So what will be vx? Vx will be v cos alpha. Here is the motion after the 1 second. So if it is the v and it making an angle theta, so this will be v cos alpha and this will be v sin alpha. That is why we are using v cos alpha as vx here. So this case is after just 1 second. 1 second. So it can be at any time. Okay, it can be at any time. Sometimes it might be this. Sometimes the position might change. We are but just taking this case. Okay, actually this is not the case. The particle while moving at the 1 second, we are taking the positions and marking the velocity there, and that velocity is actually the v. So v cos alpha for vx, and we already obtained the value for ux, that is 30 cos alpha. Since it is ax, it is 0, so when t multiplied with it, 0 get cancelled, and for vy it is v sin alpha multiplied with 30 sin alpha plus, here it is ax, ay is actually minus g, and the value of g is 10. So the time here it is 1 second. So finally we obtain some equations, and let me write it again. So to obtain 30 cos alpha, it's theta. To obtain the value for cos theta and sin theta, like in Pythagoras theorem, we know that the three sides for Pythagoras theorem, the triangle with angles 90 degree, 30 degree and 60 degree, the ratio of the sides will be 1 is to 2 is to root 3, right? Likewise, here we are considering a triangle with its sides like 5, 3 and 4. This is what the triangle. Why? Because of it's given in the question that alpha is theta is nothing but tan inverse 3 by 4. That is why we can consider the triangle will be like this. So from this we can obtain the value for sin theta, and for cos theta what we need actually. So the cos theta will be the adjacent side divided by the hypotenuse, and for the sin theta it will be opposite side divided by the hypotenuse. So you can Substitute the values over here, and for the first one it will be 30. Cos theta is nothing but 4 by 5. So your V cos alpha is now actually 24. And for the next V sin alpha, it is 30 into 3 by 5 and it is 18. Yeah, 18. No, it's not 18, it's 8. Yes, 8. And now I'm going to divide the V cos theta divided by V sin alpha. Okay, it's not like this. Yes, it's like this. So 24 by 8, what you actually get, the V will get cancelled and 8 is a multiple of 24, it's 3 times. And cos alpha by sin alpha is equal to 3. What we actually need, we need tan alpha. So tan alpha is nothing but sin alpha by cos alpha. So what is the sin alpha here? It is 1. Cos alpha is 3. So the final value for tan alpha, it is 1 by 3. And thank you for watching. Stay tuned for the next video.